Alright, let's talk about additional problem number 1 from problem set 10. And in this problem, we have two cars colliding. Your friend's car, car 1, is traveling north with some initial velocity, north. And it collides in an intersection with another car, car 2, traveling with some initial velocity. And they collide, and then they go off in a crumpled mass heap at some angle 30 degrees north of east, some v prime, so some final velocity here. And so what you're curious about in this problem is, 1, whether or not your friend was speeding, and 2, whether or not the other driver was speeding. Now, you know something else in this problem. You know the angle, but you also know that the cars, once they've collided, they travel a total distance of 56 feet, I think. 56 feet, yep. This is 56 feet. And so how do we do this problem? Well, so I think that it makes intuitive sense that they're going to slide on the pavement until friction does enough work on them to slow them down. The higher v prime, the higher the initial speed of the wreck, the further that they'll go. So there should be a direct connection between the length of the skid and the initial speed. And that is true, right? So I'm going to do that part first, okay? Because I have the work done by non-conservative forces is going to be the change in the kinetic energy. And so the work done by non-conservative forces, well, that's friction. So friction acts backward relative to the motion. So we get minus the kinetic friction coefficient, which we're told is 0.8, times the normal force, which is m total, times g, times the distance, which we'll call delta r, and that's going to be the change in the kinetic energy. Change in kinetic energy is final minus initial, but the final kinetic energy is 0. Which is minus 1/2 m, and I called it v prime squared. All right, and this is mass total here. So what we can see is that well, let me be more explicit, minus mu sub k, m total, g, delta r is minus 1/2 m total, v prime squared. Masses cancel. Minus signs cancel. And so I get a final speed, which is v prime after the collision, of 2 mu sub k, g, delta r, which is 2 times 0.8, that's the kinetic friction coefficient, times g, and what I'm going to do in this problem is I'm actually going to use English units, 32 feet per second squared, because it's a little easier in this problem, times the distance that it travels, 56 feet. If I plug that in, I got square root of 2 times 0.8 times 32 times 56, and I get what did I do wrong here? Did I do something wrong here? Square root of 2 times 0.8. Okay, so I get 53.5 feet per second. And if you convert that into miles per hour, that's 36.5 miles per hour. So we know the speed of the wreck after the collision. But during collision, momentum is conserved. Okay, so now we're going to look at during the collision. P initial is equal to P final. Okay. And so this is the total momentum, and that's an important thing to remember, that when we talk about momentum conservation, we're talking about the sum of the momenta. And so I'm going to break this down into the x direction and the y direction, since momentum is a vector. Okay. So initially, in the x direction, we have car 2, mass 2, v2 initial, and that's going to be equal to, well, mass total times v prime, but the component in the x direction is the cosine of 30 degrees. Or v2 initial, the speed of the other car is going to be m total divided by m2 v prime times the cosine of 30 degrees. And in the y direction, well, initially it was just our friend's car, mass 1, v1 initial is equal to, at the end, the total v prime, and this time we get sine of 30. Okay, or v1 initial is equal to m total divided by m1 v prime sine of 30. Now what we're given in this problem is we're given that m1g, that is the weight of your friend's car, is 2,200 pounds, and m2g is 2,600 pounds, or m total g is equal to 4,800 pounds. Okay. So if I want to find either of these speeds, the trick here is to recognize that v2 initial is, well, m total over m2. And what I'm going to do is I'm going to multiply by 1 here. This is a little algebra trick. V prime cosine of 30 degrees. All right. But 1, I can make 1 however I want. So I'm going to make 1 g over g. V prime cosine of 30 degrees. And so really what this all amounts to is that the ratio of the masses is the same as the ratio of the weights. M total g divided by m2 g, v prime cosine 30 degrees, or v2 initial is the total weight, 4,800 pounds, divided by the weight of the other car, 2,600 pounds, times the initial speed, which I found to be 36.5 miles per hour, times the cosine of 30 degrees. Plug that baby in here, we get 4,800 divided by 2,600 times 36.5 times the cosine of 30. Alright. And if I plugged everything correctly here, then I get V2 initial is 58.4 miles per hour. And I can do the same thing to find the initial speed of our friend's car. Okay. Initial speed of our friend's car. Well, that's going to be, from our expression, m total g divided by m1 g v prime, but this time times the sine 30 degrees. Okay. And so that's going to be 4,800 divided by pounds, divided by 2,200 pounds. V prime, we said, was 36.5 miles per hour. And we get the sine of 30 degrees. 800 divided by 2,200 times 36.5 times the sine of 30. If I've done everything correctly, then I get V1 initial is equal to 39.5 0.8 miles per hour. Right? Or it looks like the other car was speeding. Because V2 initial was greater than 50 miles per hour. But our car was not, because V1 initial is less than 50 miles per hour. Ta-da!